Okay, we have one more form of equation of plane called normal form. For that, we consider plane at distance d from origin. This is a required plane. Okay, this plane is at distance d from origin. Here we have origin. Okay, distance of plane from origin is d. This distance is d. Okay, and this is foot of perpendicular. Suppose this point is n. Okay, this is vector on. Okay, this is a vector on, and suppose unit vector in this direction is n cap. इस डायरेक्शन में यूनिट वेक्टर n cap है. Okay, then what will be vector on? Vector on will be d n cap. Vector on will be length of vector into unit vector in the direction of on, which is n cap. So vector on will be d n cap. Okay, then what will be position vector of point n? This end is origin. Okay, and this vector is d n cap. Then position vector of point n will be d n cap. ये होगा ना, ठीक है. Now to get the equation of plane, what we do? We consider some variable point on the plane, say point r having position vector r. Okay, then we join this 2 points. Okay, this variable point with this point. Okay, and definitely this vector will be perpendicular to this vector. ये दो vectors perpendicular होंगे ना, ठीक है ना. इनफैक्ट इस प्लेन में कोई भी जो वेक्टर होगा वो इस वेक्टर को perpendicular होगा. Any vector in this plane will be perpendicular to this vector. Okay, so this vector dot this vector will be 0. Okay, this is vector r minus d n cap. Okay, dot, and this vector is d n cap. इन दोनों का जो dot product है वो 0 होगा. ये दोनों vectors perpendicular होंगे. Okay, then we will have here d is scalar, d को cancel कर सकते हैं. Okay, so we get r dot n cap minus n dot n is 1 because n cap is unit vector, so we have here minus d. This is equal to 0. Shift d on RHS, we get equation of plane as r dot n cap is equal to d. This is a normal form of equation of plane. आप इसको याद रखें. हम इसको कहते हैं, इस फॉर्मेट का जो इक्वेशन है उसको हम कहते हैं नॉर्मल फॉर्म ऑफ इक्वेशन ऑफ प्लेन. हियर d इज डिस्टेंस ऑफ प्लेन फ्रॉम ओरिजिन एंड n कैप इज वेक्टर परपेंडिकुलर टू द प्लेन डायरेक्टेड फ्रॉम ओरिजिन. ओके, यहाँ पे जो n कैप वेक्टर है वो इस प्लेन के परपेंडिकुलर वेक्टर है जो ओरिजिन से निकल रहा है, और d जो है वो इस प्लेन का ओरिजिन से डिस्टेंस है. Like we have here equation of plane in standard form. 2x plus 3y minus 4z minus 7 is equal to 0. Suppose we are asked to write this equation in normal form. हमें इसको normal form में लिखना है, इस form में लिखना है. क्या करेंगे? We shift 7 on RHS and write this expression as dot product of two vectors. Okay, so this will be xi plus yj plus zk dot 2i plus 3j minus 4k is equal to 7. Okay, now this is position vector of variable point on the plane. This is vector r. We have here r dot. Now this is not unit vector. Okay, for normal form we must have here unit vector. तो क्या करेंगे? We divide both sides by modulus of this vector. क्या होगा इसका मॉड्यूलस? Modulus will be root 4 plus 13 plus 16, root 29. Okay, so we get r dot 2i plus 3j minus 4k over root 29 is equal to 7 over root 29. Okay, now this equation is in this form. n is form में. Here n cap is this vector, unit vector. Okay, and d is this 7 over root 29, and this is distance of plane from origin. Okay, तो अगर हमारे पास स्टैंडर्ड फॉर्म में प्लेन का इक्वेशन है if we have a equation of plane in standard form, we can find its distance from origin. Okay, suppose we have here plus 7, right? Okay, so what do you do? We transfer 7 on RHS, we will have here minus 7, then we divide both sides by minus 1, because the distance of plane from origin will be positive. Distance तो हमेशा हम positive लेते हैं, so in that case we will have here minus minus plus. Okay, so this will be minus minus plus. ठीक है, अगर यहाँ पे प्लस 7 होता तो प्लेन का इक्वेशन ये होता. यहाँ पे तो हम क्या रखेंगे, ऑन आरएचएस वी ऑलवेज मेंटेन पॉजिटिव वैल्यू, बिकॉज हम उसको डिस्टेंस कंसिडर करते हैं. ठीक है, सो इक्वेशन ऑफ प्लेन इन दिस केस विल बी आर डॉट माइनस 2i माइनस 3j प्लस 4k ओवर रूट 29 इज इक्वल टू 7 ओवर रूट 29.